OpenNMS 101 again, Module 5 continues with Part D, More DROOLS. Before continuing, there is a change. The severity of event uei.tutorial.event/alarm/resolution/A is changed from warning to normal. OpenNMS was updated with sendEvent.pl reload daemon config, where the daemon is event D. This change was verified in Carafe. This change does not affect any of the previous tutorials. Test the remaining lifecycle rules. Full cleanup applies to cleared and acknowledged alarms. The delay time is 1 day. GC applies to active and unacknowledged alarms. The delay is 3 days. fullGC applies to active and acknowledged alarms. The delay is 8 days. For training purposes, these delays are too long. How can a reasonable delay change be implemented for these rules? The cleanup rule delay is 5 minutes. It would seem appropriate to set the delay in each of the other lifecycle rules to whole multiples of 5 minutes for this tutorial. So the delay for the full cleanup rule will be changed to 10 minutes. The delay for the GC rule will be changed to 15 minutes. And the delay for the full GC rule will be changed to 20 minutes. Make the changes to opennms/etsy/alarmd/rules.d/alarmd.drl. Set the delay in full cleanup to 10 minutes. Set the delay in GC to 15 minutes. And set the delay in full GC to 20 minutes. Save and close the file. Modifying alarmd.drl requires that the alarmd daemon reload its configuration. Run send-event.pl reload daemon config -p daemon name alarmd. This is a demo of the full cleanup rule. The full cleanup rule is applied to cleared alarms that have been acknowledged. The delay is 10 minutes. A good checkpoint would be at 11 minutes. At 6 minutes after the cosmic clear is applied, check the DB to verify the alarm is still in the DB. This will verify that the cleanup rule was not applied. At 11 minutes after the cosmic clear is applied, check the DB, and if the alarm has been deleted, it means that the full cleanup rule was applied. Begin by sending 10 tutorial alert problem A events at intervals of 30 seconds. The first event was sent at 8:23:45 p.m. and the process ended at 8:28:46 p.m. Check the DB. The counter is at 10. The first event was at 20:23:45 and the last event was at 20:28:16. The alarm type is problem and the severity is warning. Change to the GUI and click on Localhost has one alarm under Nodes with pending problems. Click on the alarm ID 33. The data should match what was in the DB. Scroll to the bottom of the alarm page. Click on the Acknowledge button. After the page refreshes, scroll back down to view the acknowledgments. Return to the terminal. Send the tutorial alarm resolution A event. Check the DB. Note the alarm type is resolving. The severity is cleared. The alarm is acknowledged by def user at 20:39. The last event time is 20:40. Recheck the GUI. Refresh the alarm page. Scroll down and verify the fields match the DB. Return to the terminal. Test for the presence of the alarm in the database using the delay of the cleanup rule. The alarm is still in the database. The cleanup rule was not applied. Test for the presence of the alarm in the database using the delay of the full cleanup rule. The alarm is not in the database. The full cleanup rule was applied. This is a demo of the GC rule. The GC rule is applied to active alarms that have not been acknowledged. The tutorial delay is 15 minutes. A good checkpoint would be at 16 minutes. Check the DB at 6 minutes to verify that the cleanup rule was not applied. Check the DB at 11 minutes to verify that the full cleanup rule was not applied. Check the DB at 16 minutes to verify that the GC rule was applied. Begin by sending 10 tutorial alert problem A events at intervals of 30 seconds. The first event was sent at 8:16:37 a.m. and the process ended at 8:21:38 a.m. Check the DB. The counter is at 10. Change to the GUI and click on localhost has one alarm under nodes with pending problems. Click on the alarm ID 35. Scroll through the alarm. The data should match what was in the DB. Return to the terminal. Recall the last event time was 8:21:08 a.m. The check at 8:29:14 verifies that the cleanup rule was not applied. The alarm is still in the DB. The check at 8:35:35 verifies that the full cleanup rule was not applied. The alarm is still in the DB. At 8:37:09, the alarm is not in the DB. The rule GC was applied. This is a demo of the fullGC rule. The fullGC rule is applied to active alarms that have been acknowledged. The tutorial delay is 20 minutes. A good checkpoint would be at 21 minutes. The cleanup, full cleanup, and GC rules will be checked at appropriate intervals. Begin by sending 10 tutorial alert problem A events at intervals of 30 seconds. The first event was sent at 9:33:35 a.m. and the process ended at 9:38:36 a.m. Check the DB. The counter is at 10 and the last event time was at 9:38:05. Change to the GUI and click on localhost has one alarm under nodes with pending problems. Click on the alarm ID 37. Scroll through the alarm. The data should match what was in the DB. Click on the Acknowledge button at the bottom. After the refresh, scroll down to verify the acknowledgement. Return to the terminal. The last event time was 9:38:06, so wait until 9:44 and check the DB. The alarm is still in the DB, so the cleanup rule was not applied. Note the acknowledgement fields are still filled. Check the DB at 9:49. The alarm is still in the DB. The full cleanup rule does not apply. Check the DB at 9:54. The alarm is still in the DB. The GC rule does not apply. Check the DB at 9:59. The alarm is not in the DB. The full GC rule does apply. Each of the OpenNMS lifecycle DROOLS rules have been covered. The delay periods were adjusted for tutorial purposes. The DROOLS rules must be returned to their original delay period. Full cleanup is set to 1 day. GC is set to 3 days. And full GC is set to 8 days. Remember to send the reload daemon config for alarmd. If an event is received for a cleared alarm and the event's alarm data reduction key matches the cleared alarm's reduction key, the alarm is reactivated and the counter is incremented. This is the default behavior in OpenNMS, but it is possible to configure OpenNMS to create a new alarm based on the event's alarm data reduction key. The configuration is covered in the Horizon Operation documentation under Deep Dive, Alarms, Configure Alarms in the section Instantiate New Alarms for Existing Cleared Problems. To demonstrate, create an alarm, clear the alarm. Before the alarm is removed, send another event with a reduction key that matches the alarm's reduction key. Check the alarm status and count. Make the configuration change to alarmd.properties to verify the change. Create the alarm, clear the alarm. Before the alarm is removed, send another event with a reduction key that matches the alarm's reduction key. Check for a new alarm and count. To demo reactivating an alarm, send 10 events, each at 30-second intervals. Check the DB. Note alarm number 39 with severity warning. Check the GUI. Click on localhost has one alarm. Click on alarm number 39. Scroll up and down to check the alarm. Note the severity is warning. Return to the terminal and send the resolution event. Verify the alarm is resolved in the DB and GUI. Severity is cleared and alarm type is resolving. Return to the terminal, and before the alarm can be cleaned, resend the problem event with a higher severity, just as a point of interest. Check the DB. Alarm 39 is now alarm type problem with severity minor. Recheck the GUI and note the same. Note the related events at the top of the alarm's event list. Clear and delete the alarm by sending another resolution event and waiting for the cleanup DROOLS rule delay period of 5 minutes. There are no alarms in the database. Before proceeding, the opennms documentation references a file, alarmd.properties. That file does not exist. Use the file opennms.properties. Change directory to opennms_home/etc. Edit the file opennms.properties. Look for the commented out line with the text "New if cleared alarm exists." Copy that line, remove the comment, and change false to true. Save and close the file. Restart the OpenNMS service. For purposes of this tutorial, the limit on the SQL statement has increased to 2. To demo creating a new alarm, send 10 events, each at 30-second intervals. Check the DB. Note alarm number 42 with severity warning. Check the GUI. Click on localhost has one alarm. Click on alarm number 42. Note the severity is warning. Return to the terminal and send the resolution event. Verify the alarm is resolved in the DB and GUI. The severity is cleared and the alarm type is resolving. Return to the terminal, and before the alarm can be cleaned, resend the problem event with a higher severity. The value of 5 indicates a minor severity. Check the DB. There will be 2 alarms in OpenNMS. The last problem event created alarm number 43. Note the severity is that which was sent with the event. Alarm number 42 is still resolving and has severity cleared. Check the GUI by clicking on Alarms and All Alarms Summary. Both alarms show up. Number 42 deals with the first 10 problem events and is cleared because it received a resolution event. Number 43 deals with the last event sent with a severity of minor. Send another resolution event. This one will be applied to alarm number 43. This will clear that alarm. Note that both alarms are now cleared and resolving. The last event was sent at 10:23:10. Wait until 10:28 to verify that both alarms have been cleaned. The value of new if cleared alarm exists in opennms.properties has been set to its default value, and OpenNMS has been restarted. Up next, Module 5 continues with Part E, Alarm Escalation with DROOLS.